Once again, good afternoon to all of you. So we are left over with the safety algorithm and the bankers algorithm. So let us see how these two things will be. Bankers algorithm, detailed explanation of bankers algorithm can be taken by next coming session. Today, I'd like to go ahead and take the safety algorithm, how the safety algorithm and what is the safety sequence which we have to, which operating system will be followed. Let us see. Okay. So normally, while executing number of threads or number of processes, normally several number of resources are required while finishing up or executing of the thread and thread or process over there. So these things will be gets always in safe mode, when our operating system could be allocate all the resources required by the particular thread or the process. Okay, so the safety sequence is very important. Safety sequence must be very important while so operating this thread sequence or thread execution within the concurrent programming by any operating system. Let us consider. So let me go ahead with taking some example here. Let us consider. So this is one particular resource. This is one particular resource. Let me say this is the resource type R1, and this is another resource type R2, and then a process P2, and process or thread, whatever it may be. This is another process that is P1. So, for example, if resource 1 has allocated to process 1 and the resource 2 is allocated to process 2 and being executed, these two processes, after some amount of time, after execution of some number of instructions by process 1, it may be requested or it may be need the resource type R2. Then R2 is being held by some other process. So until the release of this particular resource by this particular process, P1 must be under waiting state. Okay, P1 must be under waiting state. Otherwise, you could also discuss this particular same scenario in terms of process 2 also. So process, resource R2 has been allocated to process 2 and it is waiting for the process resource type 1. But it is already held by process 1. Okay, so the scenario which we have to depict it here is, I'd like to introduce one particular scenario. That scenario could be seems like this. So what is the scenario here is, so at delta t1 time or t0 time, so process 1 is requested for process 1 is requested for resource type R1, and at the delta t1 time, so process 2 has requested for resource type R2, and the time being it is being continued, the same kind of execution is continued. So no other requisitions by process 1 and process 2 at this moment. Therefore, at delta T2, so-called resource, the resource 1 has been allocated to process P1. At delta T3, so process resource type R2 has been allocated to process P2 here. Sorry, it is P2. Okay. Now the process is being, so instructions of R1, P1 and P2 has been continued. After some time, probably, let me say at delta T50th time, so delta T50th time, so within this particular regard, process 1 is requested for resource type R2. At this moment, it is required. And at delta some T80th unit of time, so process 2 has been requested or required for resource type R1. Scenario will be seen in such a way. For example, so at the same time, resource 1, resource 2 cannot be required by process 1 or process 2 either. But So after some time, it may be requested. I mean, it may be requested. The process one is requested resource two, and process two is requested resource one. During that particular period of time, the operating system will always check that whether resource one is being held by process one still, or resource two is being held by process two still. It is being checked. So if that case will be there, the deadlock situation could be gets occurred. There is no safety sequence. There is no safety sequence. Instead, it would be raises. Process one will be raises one particular edge. The edge is called as a claim edge. Claim edge. This claim edge is always existed with any resource to process. Claim it in the sense, in future, look at this particular scenario that you could understand very clearly. So at delta T 50th unit of time, so-called resource 2 is required by process 1, or process 1 is required resource 2 to continue its execution. So that at the delta T naught time, delta T1 time, immediately in between these two, let me take some other color that you could understand. At delta, so 0.1 time, actually delta 0.1 time is not available in terms of this particular thing here. So at delta, oh, it is not selected. Okay. At delta, so T, let me consider T 0.1 time. So here at this place, the process will be P1 has been requested in terms of claimage form, in terms of claimage form requested to the processor, I mean, resource R type 2. Okay, so what does this particular edge means? This edge is not immediately allocates the resource. It could be allocates the resource when it could seem such kind of requisition, pure requisition, not claim requisition. Okay, pure requisition will be there, then it could be gets allocated if it is available. If it is not available, then it could be the process will be under waiting state only until the release of that particular resource which is being held by another process. Okay, at this place, so let me rewrite the same scenario one more time, then you could understand very easily. Let me rewrite the same scenario here. So at delta T naught time, so process P1 is requested, so resource type R1 at delta T1 time. At this proper process P1 is claiming the edge, not requesting, claiming the edge of resource R2. When this claim it will be converted into request in the sense when this could be available with you. Okay, then at delta T2, process P2 is requested for resource type R2, and at delta T3, the process P2 is claiming the R1 here. Okay, and similarly, so it is going on for delta 52 time. So what you call process P1 is requested. Now it is requested resource type R2. So at this point of time, it is claim the edge. In future, I may be requested this particular edge. Please allot me. That is the meaning of this kind of edge here. Now at delta 52, after processing some instructions of P1, it is looking forward that yes, I am requesting at this moment, please allocate me, something like that. So immediately operating system is looking forward that whether a resource type R2 is available or not. If it is not available, so this requested edge cannot be converted into allocated. If it is available immediately without taking any single nap, so immediately if it is available, so process one will be allocated that not like this. Resource R2 will be allocated to process. Okay, so something like this, it could be done immediately if it is available. If it is not available, then process one must be wait for some time. Okay, So soon, this process will continue for some amount of time, that is delta some 100 unit of time. Process 1 has been released this particular resource, for example, at this particular time, process 1 has released this particular resource type R2. Then what exactly this edge will be? Edge immediately converted from allocation to, so again, so claim edge. Once you have to made any climate by any process, after utilization that particular resource, so and release the resource by that particular process, it will automatically convert it into climate. If it is not climate, it is directly, so requested and allocation will be there. Then obviously, so after completion of utilization, that could be completely released from the process. Hope that you got the point here. So if you requested for climate, those climates will be again requested by the process. Yes, it could be done. If let us consider this resource is available, operating system will check that yes, this resource will be gets available. If it is available, immediately it could be gets allocated. Okay, for 47 units of time, resource 2 was utilized. Services of resource 2 was utilized by process 1. After 47 unit of time, then obviously process 1 has released, work is gets over, all work is gets over, resource 2 will be free from process 1. So initially you made it at delta T1, initially you made it as a claimant, so that it could not be released permanently, it could be converted. This allocated edge will be converted into claimant by the process 1 again. If process 1 will be terminated, okay, let me say again the continuation will be there at delta T, so 130th unit of time, yes, process 1 has been terminated. Okay, if it is terminated, then this particular resource will be completely free. Okay, so that is the allocation of edges, I mean resources, to any particular process with the claim edges. So that is what the discussion which I have made here. That is what the discussion which I have made here. So look at this. The claim edge Ti is requested for Rj indicates that the thread or process may be requested after some time in future. Once so requested resource by the Rj, Ti is requested the resource Rj, then claim edge is converted to requested edge. Claim edge is converted to requested edge. Then immediately it is going to check that operating system is going to check that whether it is available or not. If it is available, immediately so allocate that resource to the particular process or particular thread. After completion and the thread or process will be released, then the allocated edge will be reconverted into claim edge. Okay, claim edge. Once the process or thread will be gets terminated, then resource will be completely free. So this is if this kind of claim edge will be gets introduced into your concurrent systems, then safety sequence, I mean percentage of safety state will be very high. So approximately 64%, as far as textbooks are concerned, 64% of safety state will be gets existed while allocating resources to the processes. Okay. However, so if you want to achieve this particular safety state, so one of the familiar and ancient algorithm which was introduced to the operating systems, that is Banker's algorithm. Okay, let me give just a brief introduction regarding to Banker's algorithm. Banker's algorithm is always trying to make possible of so available list of resources and available list of instances of each resource. Let me say, for example, there is a printer with me. There is a printer. So how many printers are available? Let us consider in the office we do have 15 printers. So therefore 3 resource types of printers are available. So 8 gigabytes of random access memory will be there for that particular system, for example. So therefore, each 1 MB will be considered as 1 unit. Each 1 MB will be considered as one unit. Otherwise, okay, let us consider each 1 MB 1024 into 8. 1024 into 8 units of random access memory will be there with that particular. That resource type will be so 8 into so 1024. I'm unable to perform more or less some so 8100 units of units of random access memory resource types are available within that particular system. That is the meaning of instance. Okay. So, if before going to assign these instances, it is going to take some data structures to be calculated for doing some kind of resource allocation to the requested kind of threads or processes. What are those data structures will be taken? Number one, available. Okay, so here you need to understand M always represent the process or thread. M is always represented number of resources. When you have to see N within this particular discussion, N will be always the process or thread, or M will be always represented number of resource types which are available. Okay, and available of a vector, I mean a linear vector which could be having M lengths. M length in the sense M number of resource types. Okay, so then available of j equal to k instances of resource types of rj will be gets available. As I said just before, random access memory 8100 units of random access memory resource type is available. 3 printers are there, so available of printers equal to 3. Available of random access memory equal to 8100, something like that. Okay. Now then one more maximum. So this is for successful running of execution of one particular thread or one particular process. You are requested to the, you have to forward a request to the operating system. These many resource types of J. These many resource types of J. So printer is required, random access memory is required, memory cycles are required, and then hard disk memory is required. For example, 4 resources are required. Therefore, the max of I comma printer, max of I comma random access memory, max comma I of the hard disk space, something like that will be taken into consideration. When max of I comma j will be equal to k, what does it mean? The thread or process I will be requested or required to have, still more required to have this many, not still more, maximum number of things will be required by, so that particular thing is k instances of resource type rj. Single printer is required, for example, single printer is required to complete up this particular problem. So let us consider problem PID will be equal to P123. Let us consider P123 of my resource type is printer. So how many printers are required here? So one printer is required. What does it mean? So for process P123, one printer is required to complete this execution. That is the meaning. In such a way, you have to interpret. So next one is allocation. Already some resources have been allocated in terms of doing or in terms of executing its process, so progressively. Okay, it is also a matrix which is just have n by m, and here already how many number of resources type of rj will be gets required, they may be allocated with that particular system. So here you need to understand allocation will be always taking care about the claim edges. Claim edges. If claim edges will be there, allocation will be done properly. If claim edges cannot be there, banker's algorithm will be gets failed. Please remember, it's very important point. If claim edges will be there, what is the meaning of claim edge? Just before a couple of minutes ago we have discussed claim edge is a sense. So in future, that could be need by me. That is the information which is given by process to operating system. If claim edges will be there, then allocation will be very easy to banker's algorithm. If claim edges are not there, direct requisition edges will be there, banker's algorithm could be failed. Please remember this point. That this is the disadvantage of bankers algorithm. Of course, so while doing the process, always all processes or threads are requested with the claim address only. So there is no problem. Bankers algorithm is very safe to apply. Okay. And then need. Maximum is this one. Already allocated is this one. How many still required by you? How many is still required by the process? Okay. These are the four data structures which are being taken into consideration. By taking all these four, the bankers algorithm will be go for further. Let me take one example by next hour. Let me explain in detail because it is one of the questions which will be asked to you in your final examination. Let me show you. Let me show you one of the important questions because you are expected to where it is both years. Yes. Uh, yes, look into this question paper. So somewhere else it does have not here, probably somewhere else. Adlaction in both, I think. I've seen somewhere else. Yes, you can say this one. Discuss in brief about bankers algorithm, which was given for 7 marks. Last year, I have corrected the papers in Spot Center. So, what is the instructions? I am the chief of that particular paper. So, I have given clear instructions that if example will be there, 7 out of 7. If example could not be there, only 4 marks. That is what the information which I have passed to the people. Okay. So bankers algorithm is very, very simple. It is very simple. So tomorrow, I mean next hour, we will discuss the complete bankers algorithm, how it could be gets allocated. And if you have a snapshot with you, how we could get the safety sequence, let us. Okay. Thank you. So let me take attendance for a while. Please go, not go anywhere. Yeah. Thank you.